All right, day 3 of CPS 121. Taking a look at the wrong screen, I want to share and take a look at this Java screen, which is where we left off last class. We started actually jumping right into coding and being more hands-on and active instead of just me lecturing and you listening. So some highlights from last time. Up at the very beginning, we had 2 ways to set up documentation. 2 forward slashes for a single line, or a slash and an asterisk for multiple lines. So inside of this multiple lines, I might start to add things more than just name, like date. What's today's date? 8/31. What else is going on? Class, CPS 121. What is the purpose of this program? So I can put purpose of program. This is a demo program for things we are learning in chapter 2. I know chapter 2 is going to be great fun. Who is Shaka Khan? I don't know if I spelled it right or not, but I can add a whole bunch of things in the beginning of my program that can just be notes to myself. And that's purpose of the documentation. You know, I can go back and, you know, you're a 3rd semester person and you need to find something. And you don't remember exactly which program. Well, as soon as you open the program up, you may be able to look at this documentation and see what's going on. Again, line 12, public class, great fun. And you have learned that when you save this, it's going to be great fun with the Java extension added to it. And that's what you'll be uploading for me. So whatever you put public class, whatever is followed there, that has to be the name of your program. Now, shortly, I'm going to make you put your initials in front. Like I'm DPF, and I'm going to do a file save as, so I can make sure it's this. Now, why? Because I have 3 Java classes, and all oh, I didn't like that. I didn't save it to the right spot because I was talking and listening. I'm going to leave it as great fun for now. But I have 3 Java classes, which means I get 60 welcome.java programs. And when I grade the first welcome program, it's great. When I download the second one, it's welcome with 1s around it. So I have to keep going back and delete the old one I just downloaded so that I can download a new one so I'm able to grade it. So as you go through, one of the things I'd like you to do is when you name your program, and like I said, chapter 2 is great fun. That's why I called it great fun. Start to put your initials in front of it so that everybody's program is unique. All right, so great fun. We had line 14 and line 34. The first and last line of everything in my program is going to be surrounded with a left brace and a right brace. And as I told you before, the left brace and right brace, when you type the left, you should be typing the right. However far you indent the left is however far you indent the right. All right. Now, the first thing in this big body is our main, and that's the public static void and what's between the semicolons, excuse me, the left and right brace after public static main. Later, we're going to be adding more stuff into this main, into this overall program, the public class great fun, but not necessarily in the main part of it. But for now, it's kind of clean. Questions? Okay. The next thing, we started talking about data types. And the first 2 data types we talked about are int and double. So I'm going to go out in here because I'm going to make some notes. How do I make notes? I put in documentation with the double slash. So in this line in hours, I'm going to put, what did I just learn? I have 2 primitive data types. You know, again, I'm just making notes to myself. Int was one, double was the other. And we talked a little bit about int is 4 bytes of memory. Double was a lot more. But we have int hours, and we have int cost. And then we had one that was double, which was a tax. And again, this is my declaration section. So I might even want to come before where this starts and put some documentation like declaration section. So as I'm putting these notes in this program, some of you, I hope, are going, hey, yeah, this makes sense because I'm putting notes in and you're learning what the following things are. Maybe you should be putting them in your programs as well. All right, so my declaration section, that includes int hours, int cost, and double tax. They're variables that are going to be able to get values. So far, so good. The next section looks like this is where I'm going to do some work. All right, a common term instead of work is processing. So I might just put some documentation in front of there that says processing. Now, what goes on in my processing? I'm assigning values to a variable. Like I could assign tax to be 0.06. I could assign cost to equal 40 times hours plus 50. So that was my calculation. It takes the work on the right side, either a constant like 5 or an expression like 40 times hours plus 50, and assigns it over to the left side to a variable. Okay, and then a little more just review of what we did the other day. We have an area here. It looks like this is where my output is going to be. So it's my output section where I'm going to say system.out.println. Again, that's an LN in println, not a 1. I actually had 2 out of 64 students ask me about why that wasn't working, and it's deceptive because of the font. It does in fact look like a 1, not an L. We followed it with what's in parentheses is what I want to display. What's green was called a what? Anybody remember what that was called? The code that I put that turned into green. It's what's between the double quotes.
Literal string or string literal?
Yeah, thanks, Chad. It's a string literal. Right. What you see is what you get there. WYSIWYG, get it? What you type between the green is going to stick there. And then I put a plus sign, and now I can display what the variable hours was holding. And in the next line, I have a system.out.println, another string literal, the total cost is, and then a plus sign and cost. So that's where we left off. Okay, everything was good. Things were really cooking. And I said, we're about page 50 at this point. Happy? Good?
Good.
All right, excellent. We're going to go up here to our declaration section, and I'm going to add 2 more primitive data types. Okay, and again, you know, you're listening and you're watching, and you can be adding. Hopefully you're playing around in your JGrasp as well. But, oh, and wait a minute, I made a couple of changes. I want to compile it, make sure that it runs, and then I can save it. That way, if I wanted to yep, looks good. It's running. Here's the number of hours, 5. The total cost is $250 to have that stinking plumber come out. But yeah, it's good. It's all, I'm happy. And, you know, now one of the things I want to do is save it. Questions? All right. So now I'm going to add another data type. So what if I don't want to store the number 6. I don't want to store the number 8.2, but I'd like to store a letter. like capital L or lowercase a. Okay, this new data type is called char. Again, it's our next primitive data type, char, and it's going to be able to hold a single character. So I need a variable name to hold a single character. What do we want to call it?
Here.
Anything but char, right? We can call it character. That's fine. All right, so I want to go up here in my notes, and I'm going to say character, char. Char is another data type. So I'm going to change this to my notes, 3 primitive data types, int, double, and char. Now, I need to give char a value. Character equals, give me what could we have give me a character.
65.
65. How about just 6? Okay, just 6 because it has to be a single digit. So now the way I represent a character, I'm going to say character equals single quote 6 single quote semicolon. Now this is different than what we were calling a string literal earlier because that was double quotes. This is in single quotes. It holds a single thing, is a way to remember it, but a single character. So now I'm going to go around, make sure this works. System down in my output section, .out.println, string literal. Here is a character, double quotes, and I want to print out my variable name, character. And with a little luck, when I run it, it's going to print out that 6. I don't like 6. I like D. I'm going to print out a D. So now when I compile and run it, pow, I got a D. That was my best grade in college was a D. No, I'm just kidding. Everybody still with me?
Yep.
You're happy and you know it. All right, good. This is one of those deals, folks, where I get excited and I'll keep going unless you slow me down. So if you don't know what's going on, somebody holler, whoa, 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 and ask me a question, because most of the time somebody else would have the same question. All right, so my last data type is actually a Boolean data type. So in the world of computer science, this has become big, is the whole idea of Boolean, true or false, 1 or 0. So whenever I want to declare a Boolean data type, I type in Bullion, L-E-A-N. Oh, you notice it turned purple. So now you know you did it right. The funny thing with Boolean is there are languages where B-O-O-L is the name of the data type. B-O-O-L-E is the name of the data type. And for us, it's B-O-O-L-E-A-N, which is the name of a data type. Okay, so I need a variable for Boolean. I need a name. Somebody make up a name so we know it's a Boolean. It's going to be true or false.
Jacob.
How about T or F? Torf. Yeah. We can do whatever we want. So now I need to make sure up here in my notes, there are 4 primitive data types, int, double, char, Boolean. Oh, I can't spell. All right, so now I want to give that torf a value. Anybody tell any idea what value we want to give torf?
True.
True. T-R-U-E. Now, oh, it turned purple as well. Means it's a reserved word, but that's what we want. If I would have tried to put that in single quotes, it would have crashed. If I would have tried to put it in double quotes, like our string literals, it would have crashed. So it's just simply the word T-R-U-E. And I'm going to make sure this works. I'm going to put it in system.out.println. Here is a Boolean. plus TORF. And with a little luck, when I compile and run it, it does in fact compile, and it runs, and it prints out the word true. I think I need to keep taking a drink once in a while. That way it'll slow me down and give you all a chance to catch up. All right, are we happy?
Yes.
Okay. Everybody's good. All right, so I'm going to, now that I'm done all that, I think I'm going to keep all of my chapter 2 notes together. And I want to, well, we're good with that program, right? Everybody happy and likes it? Good. So I'm going to save it. And now I'm going to make a new program. So I'm going to get ready and start a new program. And I'm actually going to cheat, because here's my quick cheat. I'm going to delete everything in this body, you know, and keep the parentheses, keep public static void main args. I'm now going to change the name of this to, let's see, what I'm going to do next is learn about some of my arithmetic operators: add, subtract, multiply, divide. So I'm going to create a new program. I'm going to do public class arith operator. Now I'm going to do a file, save as, and this time I want to say arith operator, and I need to go save it in the right place, and it's going to save good. So look how much not that it's a lot, but I have some stuff already done. I have my left and right brace that go along with the class name, the public class arith operator. I already have typed in the public static void main args, so I don't have to keep looking that up. I can go up here and change the purpose of the program. Program purpose: to learn about the arithmetic operators. Okay. So now I'm going to have a little fun. Int num1, num2, semicolon. Notice I declared num1 and num2 all on the same line. I didn't say int num1, int num2. 6 of one, half a dozen of another. So you could do either one, but I want to declare two variables. They'll hold integers. I'm going to say num1 gets the value of, somebody give me a number.
7.
7. That's your lucky number? It's so lucky.
No.
Let's go with 77. It's so lucky. All right. Num2 gets the value of 13. That's not lucky. Okay. So far, so good. Anybody need 30 seconds? All right. So I can now say, okay, let's go back up and let's get some more variables. How about int sum? And I'm going to come back down to my processing section, and I'm going to say sum equals num1 minus num2. Well, if I did that, what kind of error am I probably having? If I want to find the sum and I say num1 minus num2, what type of error was that?
Logic error.
Yeah, thank you, a logic error. So let's go back and yeah, let's change that to a plus. I want to get that right. So in the world of computer science, we start to get the arithmetic operators like sum equals num1 plus num2. I'm going to go back up and I'm going to create another variable, int answer, Because as we go through here, we'll do some calculations and we'll see what comes up. All right. So now I'm going to say, all right, let's do this. In my processing section, I'm going to put answer equals num1 times 6 divided, oh, that's not through division, minus num2 plus 11. Huh. Answer equals num1 times 6 minus num2 plus 11. System.out.println. So this is just for learning purposes. The answer is plus answer. And if I run and compile it, I should get the number I get 460. Cool? Yes? Good? I have 21 people in here. I hope it's going well. Yes, it is. I should have my mask on, then you wouldn't have known it was me, right? Because they say the coronavirus is the best thing that happened to a ventriloquist.
Yeah.
Huh. All right. So this is my output.
Let's get started.
Now, I want to do this once. I can do my calculations like you see up above, but I could also do some calculations in my output section. For example, I could put system.out.println num1 plus num2. And it would actually do the calculations before it would display it. Not something you'll do a lot of. It's better to assign it to a variable and print the variable, as you'll see later. But num1 plus num2, I compile and run it, and I do in fact get 90 for an answer.
Can I write
Go ahead.
instead? Can I just write instead of num1 plus num2? I just write sum.
Yep.
SUM.
Absolutely, because we already calculated num1 plus num2 up above.
Mm-hmm.
Okay. All right. So we got something going on with there. I'm gonna go up and create a new variable int, and I'm gonna call it diff. No, that's difference. That's subtraction. Divide. I have a new variable called divide. Now I'm going to come down into my processing section, and I'm going to say divide. Divide equals num1 divided by num2. Num1 divided by num2. 77 divided by 13. Ew. Does anybody have a guess? Well, let's go to system.out.println. Type in divide is plus, and now my variable name divide. And if I run it, I see that 77 divided by 13 is 5. So let me tell you what happened. 77 is an integer data type. 13 is an integer data type. So when I put the slash in there to divide, it's doing what's called integer division. 77 integer divided by an integer is going to give me an integer. It gives me 5. Okay, there's no decimal point to it because 13 times 5 is 65, not 77. So this is called integer division. So I'm going to go to the end of that line, and I'm going to go out, divide equals num1 slash num2, and I'm going to make some notes here, integer division. And that's why I got the result that I got. I got the answer of 5. Okay? Now, another thing that goes along with that, and I'm going to declare one more integer. Now I'm going to be done with integers. We're going to move on. And I'm going to create a variable. I'm going to call it remainder. Down in my processing section, I'm going to create a statement, remainder equals num1. Now, this is called modulus. It's a way of getting the remainder. And it's this operator or the symbol, the percent sign. So if I say num1 mod num2, I'm going to make a note out here that this is called modulus. And it gives the remainder. So if I took 77 and divided by 13, I know it goes 5 times, but what's the remainder?
12.
12, good. So I'm going to put a system.out.println. The remainder is, and my variable name was remainder. So when I run and compile this, I should get that 5 for my, oh crap, I typed something wrong. For those of you that were doing your own thing, I typed remainder wrong. So if I run and compile this, I get, when I divide 77 by 13, I get 5, and the remainder is 12. Okay, let's simplify this a little bit. Let's go up and make num1 11. Let's go and make num2 2. So maybe this will make it a little simpler. When I do the divide, 11 divided by 2, I should get
5.
5. And when I do 11 modulus 2, I should get
1.
1 as the remainder. Good. So if I run this, compile, my output should say divide is 5, the remainder is 1. All right, let's see what we have as for experts. Let's go back up to num1. This time let's switch them. Let's make num1 2 and num2 11. How many times does 11 go into 2?
0.
0. So that should be my divide. And what's the remainder going to be?
2.
2. Yeah, so if I compile and run this, I see 2 divided by 11 is 0, and it does have a remainder of 2. So far, so good? All right. I'm going down and make another system.out.println. And this time, instead of working with just integers, because that's all I've done up to this point, I'm now going to do tests. So
What
let's
are
see.
num1 and num2 equaling?
Num1, I changed it to 2, and num2, I changed it to 11.
Okay, thank you.
So when I do the division, I get 0, and when I have a remainder, I get the 2. All right, let's go down to system.out.println. And I just want to monkey around a little bit down here. Instead of creating variables and creating another, what if I picked a double, like 15.5, and I put divided by 5. 15.5. So this time, that first, the numerator isn't an integer. It's a double. So now I have a double divided by an integer. And if I go ahead and run it, I'm now dealing with mixed data types. and it displays 3.1. So when I start to mix it up, it's going to take the data type that requires the most memory, which is the 15.5, which is a double. And when I divide it by an int, it's going to make my answer become a double. So far, so good? All right. Some other things that we can do. So we have all of these operators. We have add, subtract, multiply, divide, modulus. You know, I can go back up in my program wherever I want. I can do a double slash and make some notes. I can say operators, and my operators were add, subtract, multiply, divide, and the percent sign, which was for modulus.
And where are you putting these?
Anywhere I want. I just am doing a documentation and including notes inside my program.
Okay.
Yep. All right, so back down to my system, my last system.out.println. I had just done 15.5 divided by 5. It was a mixed data type, and it gave me the result of a double. So now if I went up system.out.println, and oh boy, here we go. 8 times 7 minus 6 mod 4 divided by 4.0 kind of thing. Whoo. Can you do, I'll say it again, 8 times 7 minus 6 mod 4 divided by 4.0. So by some of those rules we just talked about, can you tell me what the output should be? You may need paper and pencil on the side. I'm thinking it's going to be something like 56, and then I'm going to minus, what would 6 mod 4 be?
2.
2, and then I'm going to be, that's a 2, and then dividing that by 4.0. So after my first pass, I have 56 minus 2 divided. So my next pass would be 56 by order of operations. They still come into play. Minus, what is 2 slash 4.0?
0.5.
0.5, yeah. It would in fact be, because I have an integer divided by a double. So now I have 56 minus 0.5. I'm hoping I get the answer 55.5. Drum roll. No, that's just me amusing myself. And I get the answer, yes, 55.5. Cool beans? Net beans? Okay. All right, order of operations. Let's see what we can do now to manipulate our data, to do work, to do operations, to do calculations. I'm going to now put another system.out.println in, and this time I'm going to call on blocks of code that are already written and stored in Java in a place, in a file, in a class called math. And these blocks of code, I have to go to math. Hey, math, capital M-A-T-H. I want you to use, so I'm going to put dot, the block of code called square root. And there it's called SQRT.
The system is misspelled.
What's that? Oh, yeah. Thank you.
So you're putting this in the parentheses?
Yep. So I have system.out.println. And right in the parentheses, I'm doing this work. I could have done it up in my processing section, but I thought I'm just going to do it here for demo purposes today. This
what do you
normally
have?
would be something up in the processing section. So math dot, so hey, this block, this class, this group of blocks of code, I want to call you and I want your block of code called square root, and I want to, so I'm going to put parentheses, what is the square root of 289? And it's going to tell me what the square root of 289 is. So if I compile it, and I get a drum roll that there aren't any errors, I see that the answer is 17.0. 17 point. Do you notice what came back? What data type went in? It's called an argument here. That 289, the argument was
Integer.
And what came back?
Double.
A double, yeah. Yeah, a real number came back. So just a little side note, I'm like, yeah, okay. That sounds pretty good. System.out. So if I want to know what the square root of a number is, pow, I can just do that. Let's see. I know another one. System.out.println math.pow. Now this is another block of code that I'm going to get from this math class that's going to allow me to do powers. So if I think of a power, I think 3, that's my first number, to the 5th power. So I'm going to say math.pow 3, 5, which should give me 3 to the 5th power, which is what, 243. Nice. Well, let's see if it works first. I haven't saved in a while. So math.pow and 243. Again, it came back as a double, 243.0. I like it. I'm wondering, how would I find out if there are more of these math things somewhere? Where could I find that out? 6-letter word starts with G.
Google.
Google. Yeah. I could jump out right now of the program and go Google Java math class, because this is called a class where they're all stored. And some of you are doing that right now, and it's taking you somewhere hopefully good. What website is it taking you to? What's the first one listed? So right now you're Google Java math class, and you should see a whole bunch of blocks of code. Well, not blocks of code, but names of blocks of code.
Yeah.
What's the website it took you to?
Took me to Java Point.
Which one?
Java Point or Java Point.
Okay. Somebody else getting a different website.
Oracle.
Oracle.
Yeah.
As well.
Yeah, Oracle's a real popular one. And if you scroll up or down, do you see SQRT? Do you see MathPal? Somebody give me another one. Just, there's got to be some in there.
Cube.
What is it?
Uber.
CubeRoot? How?
Yep.
I never used that one. What is it?
It's math dot CBRT.
CBRT. Huh. Cube root of 243. Wonder what the cube root of 243. How about the cube root of 81? Let's do something we might know. Cube root of 81. I can't spell again. System.out.println. Cubed root of 81. And I bet it returns it as a double again. Uh-oh, 81,
Wait,
3
how do
times.
you put in the parentheses to do the cube root?
Yeah, I got it. So the cube root of 81 is 4.3 Da 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 da. I was thinking the cube root of 27. We know that one. That should be 3, right? Cube root of 27. But nice. It gives us a cube root.
It's math dot what?
CBRT.
RT. Okay.
I have to say that's one I've never used.
And the numbers you used were what?
81. And it gave me 4.3267. Okay, I'm going to stop right there for today and stop recording.